short answer part 5. If you're hanging with me, this one video is going to be a little bit longer, but it's short answers. And I think these are actually 5 like really good short answers, like super similar to something I think you might see. And hopefully, right, you start to recognize I don't know, it's a trend, right? You kind of see the same questions over and over again, right? So if you're watching these videos, good on you. First one's a 2-pointer, right? Over the set of integers, factor the expression completely, right? First, right off the bat, right, I see that it's factoring, right, which means I'm not setting it equal to 0. I'm not trying to get answers. I just want to factor. I always said, right, in class, I'm looking for the first thing. I'm always looking for the GCF first. So right off the bat, I see there's a GCF. That GCF is X. I'm going to rewrite everything, right? It's going to make my life a lot easier in a minute. So I'm going to say 2x to the power 3 minus 10x squared plus 3x minus 15, right? All I did was take out x from all my terms, right? And then, right, I see 1, 2, 3, 4 terms. That means let me factor by grouping. So I look at my first 2 terms. What's my GCF here? I know I can take out a 2. And, right, I know I can also take out an x squared, right? What does that leave me with? Leaves me with x minus 5. I'm looking at my last 2 terms, right? What can I take out here? Looks like a positive 3. Positive 3 makes me happy because what's left? X minus 5. Wow, look at that, right? These have to be the same. Don't forget about this x. I just do this for one time, brackets, right? Bring the x down. But then in the next one, right, I'm going to get rid of the brackets because the x comes down again. I take my 2 terms that were outside, 2x squared plus 3. And then also my x minus 5, right? The ones that are the same is only one factor. I kind of look at it. I can't really do anything else with this, especially it kind of says over the set of integers. If I tried to factor this, you get a negative, which would be an imaginary number, so it doesn't work. Guess what? You're done. I feel like that one wasn't that bad. Moving on, another 2-pointer, right? The monthly unemployment rate of towns in the United States is approximately normally distributed with a mean rate of 5.2% and a standard deviation of 1.6%. Determine the percentage of towns, the nearest integer, that have a monthly unemployment rate of greater than 6%. So I see this, right? I see this greater than 6%, right? Right off the bat, I'm going to my calculator, right? And I'm going to second distribution, right? I'll even put it over here, right? You should be going to your calculator, second, the second button. God, that was bad. Second button. And then go to distribution, right? Which is like the VARS button. D-I-S-T-R. Once I go to that, right, I'm going to go into my normal CDF, right? Which is like button number 2, normal CDF. When I click that button, right, it wants me to do a lower, an upper, a mean, and a standard deviation. So my lower is going to be, I know it's got to be greater than 6%, so I'm going to say my lower is 6. My upper, you're just going to make a big number. So in this case, I'm going to hit 100, right? Because it's a big number, right? It can't be more than 100% anyway. My mean is what? 5.2. And then my standard deviation is 1.6. Like I said, if you show this, right, on your paper that you went to your calculator and you did this, whoops, you would get full credit. Press enter. What do I got? I get a number like this, 0.3085, right? If I'm thinking about percentage, I have to multiply this, right, by 100. It's going to be 30.8, but they want the nearest integer. So my only answer to put down is 31%. And I'm good to go, right? Do not skip this last step. Make sure, they're always going to try to trip you up with things like this, right? Nearest integer means it has to be a whole number. Cool. Number 3, right? When you have 1 over, this is the cube root of y squared times y to the power 4. It's written in just one form, y to the power of n. What is the value of n? Justify your answer. So for this one, I don't know. I mean, there's a bunch of ways to do this. I'm just going to start by thinking, right? Let's see. This is almost like saying y to the power 4 over 1. So if I multiply this, right, and I'm like multiplying fractions, my first step is going to look at this. Y to the power 4 all over that cube root of y squared. And then since you want to get it in this form of y to the power of n, that means I want to turn everything into fractions, right? So I'm just going to say y to the power 4, right, because that can be a fraction. If I turn this into a fraction, right, I've said it a couple times now, but the power always goes to the top of the fraction, root goes to the bottom. Now, right, I know if I'm dividing same bases, what am I doing with my exponents? I'm subtracting, so I'm going to say 4 minus 2 over 3. I get 3.3333 repeating. I don't really like that, so I'm just going to go to math and turn it into a fraction, which is y to the power of 10 over 3, right? But I'm not done, because what are they looking for? They're looking for the value of n. They don't want to see this, right? Another one where they're kind of just being annoying, right? But you want to say, well, what is the value of n? The value of n is 10 over 3. I don't like questions like number 2 and 3, because you can do like all the math correctly and still lose points because you just not reading, I don't know, correctly, things like that. But I don't know. I don't like the tests. Moving on. Number 4. This is a 4-pointer, right? But a 4-pointer, but one that I don't think is bad, because what are they looking for, right? They're giving you the population in China is given by this function, and then the population of India is given by this table, right? What are we looking for? Which countries' population had a greater rate of change between 1950 and 2020? Rate of change, right, is always going to be the change in outputs over the change in inputs. If I look at China, right, what am I going to start? I'm going to start by taking this function and plugging in what? The rate of change since 1950 and 2020, right? So, sorry, the number of years since 1900, right? So that means if I'm looking between 1950 and 2020, I want to take, right, P of 50, because that's 50 years past, and also the P of 120, right? Because that would be 120 years have passed between 1900 and 2020. I plug that in. So I'm going to say 316.93 times e to the power of 0.0133 times 50. I'm doing the same thing over here. In this case, 120. I'm actually doing the harder one first. What do I get as an answer here? Let's see. You're gonna have to give me a second because I don't have my piece of paper with me right now. But 616 points. We'll say time 0.27, right? If I do the same thing, right? I'm going to do it again, and this time it's going to be times 120. I get 1,563 points. We're just going to keep it at 0.49, right? So now I'm taking my outputs, right? So I'm going to say my outputs is 1,563.49 minus 616.27 all over what? 120 was my input minus 50. Sorry, my hand is like cramping up right now. Minus What do I get? Like 947.23 divided by 70. What do I get? 13.5. We'll keep it at, right? So that's like 13.5 million, right? Change it over to red, right? Now I'm looking at India. Well, India is a little bit easier because they're giving us all the info. So 1950 would be 50 years. And then, of course, 2020 would be 120 years. I have to just say, well, what was my outputs? My outputs were 1,380 minus 376.3 all over what? 120 minus 50. What does that leave me with? 1,003.7 all over 70. And you're getting what? 14.3, right? So make sure, right, at the end, right, I got my two average rates of change. Don't do all this work and then not justify your answer. You would have to say, right, India had a greater rate of change because 14.3 is greater than 13.5. If you did that, you'd be in good shape. Love it. And the last one, right? Another 4-pointer. Solve the system of equations shown below algebraically. Algebraically means, right, we got to make sure we can't just put this stuff into our calculator and get the points, right? We actually have to do the work. Right off the bat, right, I'm going to just try to make it easier on myself, right, and solve for my second equation, right? So I'm going to start by just saying adding y on both sides. So I know x equals y plus 6. And then I'm going to substitute it into my first equation, right? So if I come down, I know x equals y plus 6. So my first little piece is going to be y plus 6 minus 4, all of that squared, plus y minus 1 squared equals 9. Over here, that's leaving me with what? Y plus 2 squared. So I'm just going to skip that step and then basically square everything out, right? So y plus 2, let me just show it, right? Because right, that's going to be squared. That gives me y squared plus 4y plus 4. And over here, right, if I'm squaring out this, I'm getting y squared minus 2y plus 1 equals 9. Let me start to add like terms. I'm getting what? 2y squared plus 2y. 4y minus 2y gives me 2y. I have a plus 4 plus 1 plus 5 equals 9. If I want to see right now, I know I have to factor, so I want to get this side equal to 0. I subtract 9 on both sides. That leaves me with what? 2y squared plus 2y minus 4 equals 0. Now I want to factor, right? But look, I see a GCF, right? So if I bring this work up so we don't run out of space, I can take out that GCF of 2, kind of just make it disappear. So I'm going to be left with what? Y squared plus y minus 2 equals 0. This becomes an easy factor now, right? Because I'm basically just saying, well, I need to know two numbers, right, that multiply to negative 2 but add up to 1. That's going to be plus 2 minus 1. Solve for y. So my first values are y equals negative 2, y equals positive 1. But I'm not done. I have to find the x values for both. So let me go back and, right, if I know, right, I got my y values over here, so I'm just going to plug them into this equation, right? X equals what? X equals basically -2 plus 6. So X equals 4. And then also X equals 1 plus 6. So X equals 7. Still not done, right? Because I have to have, right, 2 answers. So when I put up, right, make sure you have your answer choices as what? My first one, I'm just going to keep it at 1, 7. And my second answer would be 4, -2. I'm good to go.